In this lecture, we'll be talking about data transformation and exploration and how to use some of the functions from the dplyr package, which is part of the family of data science packages in R called the tidyverse. So let's talk about a motivation. Generally, sometimes you need to create some new variables, perform some summaries, or maybe you just want to rename the variables and reorder the observations that you have to make the data work and the data analysis easier for you. We will focus on the dplyr package, which is, as I mentioned, a core member of the tidyverse, and also we'll be using data from the NYC Flights 13 dataset. This is a dataset that contains every single flight that left the city of New York in the year 2013 from their 3 different airports. The dataset that we'll be using for illustration is the flights data frame, which is part of the NYC Flights 13 package. It contains more than 300,000 rows, where every row represents a flight that left the city of New York in the year 2013. Originally, this collection of observations was compiled from the US Bureau of Transportation Statistics, and you can find more information about it in the documentation of the package. So let's introduce dplyr. dplyr basics include at least these 6 different verbs or functions. Sometimes you want to pick observations by their value or condition, and this can be accomplished using the filter function. Other times you want to reorder the rows, and there is a handy function for that called arrange. Other times you want to pick variables by their name, and you want to reorder the set of attributes that you have in your data frame. You can accomplish that via the select function. And finally, number 4, you can create new variables with functions of existing variables. So you can use mutate for this. The other 2 set of functions that are generally used combined are the summarize function and the group by function. So both of these you use when you want to collapse many values down to a single summary and you want to operate on a group by group basis. So let's talk about filter, which, as I mentioned, filters rows of your data frame. And remember that in our assumptions, every row represents one single observation. Filter allows you to subset observation based on their values. And the example that I'm showing in this set of slides says that we want to filter all the flights that left New York City on the first month of the year and the first day of the year. So all of these observations that you will be returning after applying the filter function to the flights data frame with these 2 conditions represent the collection of flights that left New York City on January 1st. dplyr functions never modify their inputs, so if you really want to save the result, you will need to use the assignment operator, the left-hand arrow operator. So in this case, we are assigning the output of this filtering function to a new object in R called January 1st. To use filtering effectively, you will have to practice with the comparison operators, and R comes with a variety of them that are very useful when performing any type of data analysis. This includes things like comparing when observations are greater or less than some given value, when they're not equal to something, or when they're exactly equal to something else through the double equal sign operator. For instance, suppose you want to obtain every single flight that left the city of New York in the year 2013 in the month of November or December. November and December in this data set are represented by the months 11 and 12. So you can use the OR operator as we're showing on the first chunk of code, or another possibility is to use what we call the membership operator, that is the percent in percent. And in that case, you can modify this type of operation by simply saying that you want the month for which is either 11 or 12, representing November or December. Moving on to the next function that is basic from the dplyr package, here's arrange, which works similarly to filter, except that instead of selecting rows, it will change their order. So it will take a data frame and a set of column names to order by. For instance, sometimes we want to order the set of observations that we have in descending order by the arrival delay of a given flight. And to apply that, you can use the last piece of code that is included in this slide. Another function is the select function, which allows you to rapidly zoom in on a useful subset using the names of the variables that you want to focus your attention on. Select will literally pick columns in your data frame. And remember that in our case, columns represents the attributes of our observations. There are a number of helper functions that you can use with select. Some of them are the starts with function that will match a name that begins with the string that you give as input. Also, a function called ends with or the function contains when you cannot really remember the exact spelling of the attribute name, but you know that it contains a certain pattern. We're going to start getting ready to create new variables based on information that we have, and that is the job of the mutate function. The mutate function adds new columns that are functions of existing columns. To illustrate this concept, we're going to create a smaller data set with less columns since the NYC Flight 13 package, and in particular the flights data frame that comes with it, contains a lot of information. So in this case, we're only going to focus on information representing the year, the month, and the day of that flight. Any column or any attribute that ends with the word delay, such as departure delay or arrival delay, will also capture distance and finally the airtime. As a simple example of how mutate operates, we can use some of the attributes that we reserve for this dataset called flight_SML for small and create new variables such as gain, which will be nothing but the difference between the arrival delay and the departure delay. And since we also collected distance and airtime, we could have an estimate of the speed of that flight using distance over airtime times 60. Let's talk about summarize, and you'll find that summarize is sometimes spelled with an S, sometimes it's spelled with a Z, and they are the exact same function. Now, summarize collapses a data frame to one single row for one single piece of information. In this case, if I use the summarize function to compute the average departure delay of every single flight, so these are more than 300,000 flights that are collected in the flights data frame, you'll find that the average departure delay of the entire data set is 12.6, and the units in this case are minutes. The summarize function is useful when you pair it with the group by function, and in this way the analysis can be done for individual groups. Before we do that, we need to introduce a new operator in R, particularly from the migrator package, which is also embedded into the tidyverse. The pipe operator will allow you to connect multiple instructions like the ones that we just discovered in a collection of steps. The pipe operator may remind you of your favorite video game, Mario Bros, when you would pipe Mario, or Mario will go on a pipe from left to right and it will flow that way. So in this case, we're going to flow information from left to right through the pipe operator, which in R is given by the % greater than %. To show you a quick example of how easy it is to use the pipe operator, let's take a look at the code on the right-hand side of this slide, which says that we want to create a vector that goes from 1 to 8. We want to sum every single entry. Then we want to take the square root of that. And finally, we want to take the logarithm of it. That then is equivalent to concatenating this set of instructions such as sum from 1 through 8, and then pipe that into the square root function and pipe that into the logarithm function. You can see some of the benefits already, and that is that it's a lot cleaner to read this code on the left than it is to make modifications on the code on the right. So the pipe operator will send the output of the left-hand side function to the first argument of the right-hand side function. To show the power of the pipe operator and some of the verbs that we have learned from the dplyr package, here's a situation that you may encounter. Think about you wanting to explore the relationship between the distance and the average delay for each location. This could be done in a variety of ways, but let's do it in these 3 steps. You can think of grouping your flights by destination. Then you will like to summarize to compute the distance, the average delay, and perhaps the number of flights. And finally, you may want to consider filtering out your data to remove any noisy points, such as those flights that went to Hawaii. which is almost twice as far as the next closest airport. Let's see how to solve that type of question using the power of the pipe operator and the function from dplyr. The first thing that we'll do is to take the data frame and pipe that data frame to the group by function, where we'll be grouping by destination. Then we'll summarize by creating three types of summaries. The first one is counting how many observations in each group. The second one is to get the average distance covered by that flight. And the last one is to get the average arrival delay. Finally, we'll pipe that into the filter function to filter out some observations. We're going to ignore the ones for which the number of flights is less than 20, and also we're going to remove the ones whose destination was Honolulu Airport. If you use RStudio, you can type the pipe operator with this shortcut, Control-Shift-M. And if you have a Mac, you can use the Command-Shift-M as a shortcut for the pipe operator. One thing to notice is that you can read it as a series of imperative statements. Every time you find the pipe operator, think it in your head as then. I do this, and then I do that. So for instance, in this case, we group, then we summarize, and then we filter. You may have noticed in the sequence of steps that we showed to solve that questions about the average delay per destination that we use a specific argument in the function mean that computes the average. That argument was the na.rm equals true. The reason for that is that aggregation functions obey the usual rule of missing values. If there is any missing value in the input, the output will be a missing value. This is the way that R has to give you a warning that you have some missing observations in the particular attribute that you're trying to do a computation. Fortunately, all aggregation functions have an na.rm argument, which will remove the missing values prior to computations. That is the reason why we took flights, then we group by year, month, and day, and then you can summarize by computing the average departure delay per year, per month, and per day to try to answer a question such as, what is the worst day of the year to leave New York City?